Hello, welcome to our demo video for Signapse. Signapse is an open source software tool for helping everyday people learn sign language for free on Ubuntu and Raspbian platforms. Signapse includes a deep learning model to help recognise and identify hand signs in a live camera feed, providing the user with real-time feedback on their signing. Users are able to complete learning challenges and view their live signing in our GUI. The main effort in software architecture design has been for the Signapse video processing pipeline. Pipeline links have been crafted to adhere strongly to solid object-oriented principles. The initial element, camera, creates events. These are passed along pipeline links and consumed by the GUI. Along the way, various pipeline links process these events, modifying the data and passing downstream. Callbacks deal with the type scene, which has been created to store information about a given camera frame, including metadata and the frame pixel values. A custom GUI was created to make the system more intuitive. Signapse has a soft real-time requirement. The frame rate at the GUI must be as high as possible while processing a maximum amount of frames with the CNN. A challenge emerges when consideration is given to the CNN execution latency for processing a single scene. Testing reveals that on a desktop Ubuntu machine with moderate specs, execution latency is around 80 milliseconds, and in Raspberry Pi this increases to around 660 milliseconds. In both cases, processing every frame with the CNN would not satisfy a basic minimal frame rate of approximately 15 frames per second. We have provided an object-oriented approach to decouple latency-bound processing elements from affecting video pipeline throughput. More information can be found on our GitHub. Signapse also has some hard real-time requirements: button presses, camera latency, and mouse and keyboard input. These have all been dealt with by selecting appropriate technologies to abstract hardware interaction. This makes the application cross-platform and reliant on mature software packages. Signapse successfully meets all of its real-time programming requirements while providing an object-oriented design pattern for future modification. To recognise hand signs in the camera feed, Signapse makes use of a convolutional neural network, or CNN, classifier. This is an image processing neural network that produces an output for the likelihood of what sign is within the input image. This necessitates video processing to be performed on a per image basis, a large motivation for our video pipeline structure. CNN's classifiers typically output multiple values with a range of confidences. We simplify this to one maximum confidence value per input. To keep things simple, we have decided to only classify between a set of alphabet hand signs with a view to expand to more complex signs in the future. After some experimentation, we found the best architecture to use was a MobileNet v2 model. This network is suitably lightweight for real-time applications, while still providing enough grunt for distinguishing between 26 hand signs in the alphabet. Our instance of MobileNet v2 is generated with TensorFlow and Keras and exported to the .pb format for use with OpenCV runtime. Our MobileNet v2 instance is trained using a transfer learning approach. Thank you for listening and have fun signing in Signapse.